Hi all, in this video, we are going to learn about JVM architecture. So in the previous video, we learned about JVM, where we discussed about the write once run anywhere approach. So here I will just brief that approach. So in Java, after we write a Java program, we will be saving that program with the .java extension. And after the compilation, a .class file will be generated for this Java file. This .class file contains the bytecode representation of the source file. And we say that this bytecode is platform independent, as this bytecode can be taken to any other machine, any other platform with that platform specific or machine specific JVM installed. Let's see this with an example. Consider that I am having a Windows OS system and I have developed a Java program in my Windows OS system. And I have compiled the program and a .class file is generated. But I need to take this bytecode file, this .class file, into a Linux system. And we say that bytecode is platform independent, so this is possible. We can take this bytecode file, this .class file, into the Linux system and we can run it there. But we need to have a Linux specific JVM installed into that machine. That's what we said about the write once run anywhere approach. So in this video, we will be learning about this JVM's architecture and how this JVM is executing the bytecode file. So let's move into the video, and here we can see that the JVM consists of three distinct components: class loader, runtime data area or memory area, and the execution engine. In this video, we will be focusing on to the class loader. So let's see the class loader in detail. So as we said, when we compile a .java file and it is converted into the bytecode file, we will be having this .class file with us. We have already said about this and we are familiarized with this concept and it is clear to us. And after compiling it, and while we are trying to use this class in our program, the class loader will be loading this .class file into the main memory. And the first class to be loaded into the main memory is the class that contains the main method. And in the class loading step itself, we are having three different phases: loading, linking, and initialization. And in the loading phase, it actually loads the binary representation of the class, that is this .class file, and it will be generating the original class or original interface from this bytecode representation. So here in the loading, we can see that there are three built-in class loaders: bootstrap class loader, extension class loader, and application class loader. So this bootstrap class loader is the root class loader, and this bootstrap class loader will be loading the standard Java packages like java.lang, java.net, java.util. These standard Java packages will be loaded into the into the memory by the bootstrap class loader. When we print something, we use the command system.out.println in our code. So this is class in the system.out.println is imported from the java.lang package. And we said that the bootstrap class loader is responsible for loading the standard Java package like java.lang and util. So here, actually, we don't need to do anything explicitly while we are using system.out.println. It will be automatically loaded by the bootstrap class loader. And the next is extension class loader. And the extension class loader is the subclass of bootstrap class loader. And it will be loading the extensions of standard Java libraries. For example, if you are using Java extensions like JDBC connector, then the extension class loader will load these libraries into the JVM. And next is application class loader. Application class loader is the final class loader and it is the subclass of extension class loader. The application class loader will be loading the files present in the class path. By default, the class path will be the current directory of the application, and we can also modify the class path using the -cp or -class path command. This is about three different types of class loaders, and the next is linking. Till now, we had discussed about loading and different types of class loaders. And after the loading phase, all the required classes will be loaded into the memory. And loading the classes is done by the respective class loaders. The standard Java libraries will be loaded by the Bootstrap class loader, extension will be loaded by the extension class loader, and the classes in the current directory or in the specified directory will be loaded to the memory by the application class loader. And the next is linking phase. So let's see what happens in the linking phase. Linking, as the name suggests, it involves combining or linking the different elements or dependencies of the program together. Linking involves three steps: verification, preparation, and resolution. And in the verification step, it checks for the structural correctness of the .class file by checking it against a set of rules. So if the verification fails, we will be getting a verify exception. Consider that we have built a program in using the Java 11 and we are running that code in a system that has Java 8 installed. Then the verification phase will fail and we will get a verify exception. That's what verification is. And in the preparation step, the JVM will be allocating memory for static field of a class or interface, and it will be initializing them with default values. For example, consider that in our class, we have defined a field value like this: private static final boolean value equal to true. We have defined the value field as static. So in the preparation phase, JVM will be allocating memory for the field value. So in the preparation phase, JVM allocated memory for the field value, and then it will be initializing the field with default value. So here the type of value is Boolean and the default value of Boolean is false. So in the preparation phase, the value field will be getting the value, it will be initialized with the value false. And that's what preparation means. The next is resolution phase. And during this phase, the symbolic reference will be replaced with direct references. That is, if you are having references to the constants that are defined in other classes, that is, if you are having a class, if you're having classes class A and class B, and class A is having reference to the class B, and class B is having some constants defined in it, then class A is referring to the constants in the class B, then that reference will be resolved at this phase and it will be replaced with the actual references. That's what happens in the resolution phase. And in the initialization phase, it involves executing the initialization method of a class or interface, and it can also include calling the class constructor, executing the static block, and assigning values to all the static variables. This will be the final stage of class loader. For example, we have seen this code before in the preparation phase where the field value was allocated memory and it was initialized with the default value of the type Boolean, which was false. So in the initialization phase, the field will be initialized with the actual value. That is, before at the preparation phase, the value was initialized with the default value, which was actually false. Now that will be replaced with the actual value, true, in the initialization phase. So in the initialization phase, what happens is that it will be calling the class constructors, it will be executing the static blocks, and also it will be assigning values to all static variables. And here comes the conclusion for all the steps in class loader. So we have seen the class loader in detail, where we discussed about the loading, linking, and initialization phase. And in the loading phase, we have said that these different class loaders will be loading the respective classes into the memory. And if any of these class loaders is not able to load the class, like if the Bootstrap class loader is not able to load the class into the memory, it will delegate its task to the extension class loader. And if the extension class loader also couldn't find the class, then it will delegate the task to application class loader. And even after application class loader is not able to load the class file, then we will be getting the class not found exception. And we had discussed about other details of loading step and the linking and initialization step. I hope it's clear. We can see the rest of the JVM architecture in the coming videos. Thank you for watching.